Hi, everyone. First of all, thanks to everyone before me who gave these enlightening talks today on feature flags and OpenFeature. My lightning talk is called No More If-else Soup, and it's all about building scalable feature flag architecture using design patterns. So first, something about me. My name is Gaurika Poplai. I'm a software engineer at Microsoft. I have around 3 years of full stack experience. I'm part of the Azure storage team. And as part of that team, I've contributed to 3 different Azure offerings for data ingestion, both online and offline data ingestion services. And my interests are in distributed systems, security, platform engineering, observability. OK, let's get into it. Let's look at the code on the left. One feature flag seems harmless, but as we add more, new pricing rules, telemetry, experiments, each flag becomes another conditional branch. Pretty soon, a simple order processing function turns into if-else soup, messy, hard to reason about, and even harder to test. And flags don't stay in one place either. The front end might control a layout, the backend might toggle a new API, SDKs use their own config, and suddenly every user hits a different combination of flags. When something breaks, debugging becomes guesswork, and rollbacks get risky. This is the problem we're trying to solve, keeping flexibility without ending up with tangled logic. OK. Feature flags are great for flexibility. But flexibility without structure becomes chaos. Every flag adds a decision point, and when those decisions spread across layers, we lose control. Design patterns sit on the other side. They give us structure and intention. They help us encapsulate behavior so the architecture stays clear. So what if we combined these two? Instead of sprinkling flag checks everywhere, we can use design patterns. These two ideas rarely get discussed together, but pairing them gives us the best of both worlds, flexibility with maintainability. So this is the core idea. It's a shift in mindset. Instead of sprinkling if-else statements everywhere, treat a feature flag as an architectural input, something that feeds into a well-defined pattern or component. The flag doesn't decide what code path to run directly. It simply selects which implementation should be active. This way, your code becomes testable, composable, and reversible, because you're swapping behavior, not rewriting logic. By layering your system this way, feature flag stops being conditional switches. They become configuration for architecture. That's when you move from reactive flag use to intentional flag design. All right, let's get into the fun part, the deep dives. From here on, we're going to look at real practical use cases. I'll walk through 5 patterns you already know: strategy, decorator, etc. But this time through the lens of feature flag behavior. OK, so let's start with a super common scenario: pricing logic in e-commerce. You've got promotional discounts, membership discounts, seasonal specials, all of which follow slightly different algorithms. And of course, product wants to A/B test them. So on the right, you see the code that you would generally write, pseudocode you would generally write for implementing this. Now we'll talk about what's wrong with this and how it can be improved. So for this kind of scenario is where the strategy pattern fits perfectly. Strategy is a behavioral pattern that lets you swap algorithms at runtime. Instead of scattering those decisions across the code base, you inject the algorithm you want to use. For A/B testing, this is gold. The flag doesn't toggle logic inside a single giant function. Instead, it simply decides which strategy to inject. The benefits are huge. Clean separation of concerns because each strategy handles just one behavior. You can unit test every strategy independently. And adding new behaviors is simple. You just create a new strategy class. So I'll move to the next scenario. In this scenario, we've got a simple core service that processes an order. But in the real world, we often want to sprinkle in optional behavior, like telemetry, caching, extra logging, maybe audit trails. All of these are toggled with feature flags. Again, on the right, you'll see pseudocode for how you'd usually implement this. And now, in the next slide, I'll tell you which design pattern you can use to improve this code. Yeah. So for this kind of scenario is where the decorator pattern shines. The decorator is a structural pattern that lets us attach new behavior to an object without touching the object itself. Instead of stuffing more if checks around the core service, wrap it with small focused decorators. This works perfectly for optional enhancements like telemetry, caching, etc. Each enhancement becomes its own decorator, and the flag simply decides whether that decorator gets applied or not. The beauty here is that the core service stays totally untouched. It doesn't know or care which optional features exist. You can stack multiple decorators in any order. I'll go to the next scenario. So in this example, we're toggling between Stripe and PayPal using a feature flag, which is pretty common during migrations or experiments. The problem is that each SDK has its own quirks. Different method names, different parameters, different error formats. When we wire this directly into an if-else block, the business logic ends up knowing all of those differences. That means the app is now tightly coupled to two third-party APIs. Again, on the right, you will see a common implementation of how we would usually go about implementing this. Yeah, so for this scenario, the adapter pattern is the perfect fit for this situation. The whole idea behind an adapter is to bridge two incompatible interfaces, so your application can talk to them in a uniform way. Instead of letting your business logic deal with Stripe's interface or PayPal's interface, you create a thin adapter layer for each SDK. Now, your application only needs to call a single stable method like process payment. The adapter handles all the messy details, converting currencies, formatting parameters, calling the right SDK methods, catching their weird errors, all of that. Okay. Moving to the next scenario that I'd like to talk about. In this payment example, we want to optionally enable fraud detection using a feature flag. But the core payment logic should stay clean. Maybe it's a new system we are testing, or maybe it's only enabled for certain regions or user segments. Again, on the right, you'll check how you can see how we would usually implement this. Yeah. And this is where the middleware pattern fits really well. Middleware lets us handle requests through a chain of components, each able to run its own logic before passing the request along. For our fraud detection example, we can move the fraud check into its own middleware step and let the feature flag decide whether that step is included. The core payment service stays untouched and doesn't need to know about optional behaviors. And because middleware is composable, we can stack fraud checks, audit locking, etc. in a clear ordered pipeline. Yeah, now I'd like to discuss a scenario on the front-end side of things. So in this user interface example that you see on the screen, an e-commerce site wants to roll out a new homepage layout to a subset of users, while the rest continue seeing the old one. A feature flag makes that possible without redeploying code, which is great for experimentation. But here, the layout decision is happening directly inside the JSX. Now, at Microsoft, I've worked on the Azure portal, and myself, I have kind of written this kind of code with feature flags a lot of times. And here's how you can improve it. So let's talk about component composition. It's all about building UI by assembling small reusable pieces. And it works beautifully with feature flags. Instead of mixing flag checks directly into the JSX, we wrap the logic inside a dedicated feature component. This component handles the flag lookup, decides whether it's enabled, and then either renders the children or the fallback. That keeps all the branching logic encapsulated and out of the main UI. Yeah, so I'd like to wrap up my lightning talk with this blueprint, which has these 4 steps: identify the flag type, choose the right pattern, centralize evaluation. And you get a scalable, maintainable approach to feature flagging across your entire stack. When we talk about identifying the flag type in this blueprint, we don't just mean is it a Boolean or a string. We mean understanding the kind of decision the flag is driving. Is it selecting between two behaviors, or is it wrapping optional enhancement, or is it doing something else? But the real glue that holds all of this together is OpenFeature. OpenFeature becomes the centralized evaluation layer between every pattern we discussed. Yeah, thank you. I think I'm over time by 2 minutes.
Oh, you did great. Yeah.